All right, Elaine has a business repairing home computers. She charges a base fee of 30 for each visit. That means she comes to your house. I talked to somebody about this the other day. She comes to your house, she's going to charge $30 straight away. So also she charges $35 an hour for her labor. And they give you then the function rule here. Cost is 35 times the number of hours plus 30. And would you ever have a cost? Well, would you ever have a situation where it took her 0 hours to do it? Well, imagine this. You call her up and you say, Elaine, I need you to come out to my house. My computer isn't functioning. And she shows up and immediately on walking in the door, she says, your computer's unplugged. And she plugs it in and boom, it works fine. And how long did she work for? She really worked for 5 seconds, which is essentially 0 hours. So she's going to charge you for 0 hours. She didn't really do any length of time, any length of work really there. But she does get that $30. So the cost is going to be $30. She says, well, I showed up. I charge you 30. Okay. Versus she is there for an hour and she says, okay, I'm going to charge you $35 times 1 hour, 35, plus that $30 fee for showing up, $65. Okay. Or if she was there for 2 hours, 35 times 2 is 70, plus 30 is 100. Or she could be there for 3 hours and it is $105. 35 times 3 is 105, plus 30 is 135. You can see that as you increase the number of hours here by 1, 1, 1, this goes up by 35, 35, 35, and that's because that number there is 35. Okay. Um, is it possible for her to work for part of an hour? Yeah, actually, unless she had a rule that says, I'm going to charge you the next full hour. So once I start working, you're going to get charged for an hour. If I run into the second hour, I'll charge you for the second hour too. And then that would be a situation where it wouldn't be just a straight linear situation that is continuous. But yeah, she could work any number of minutes and seconds in between there, which is some fraction of an hour. And you could potentially have values between 0 and 1, between 1 and 2, and connect them. So since it doesn't limit us by saying that she doesn't do that, we'll connect this. Okay, so how do we graph it? It says use the function rule to make a table of values, which we did, and a graph. So if we wanted to make our graph, I'm going to label the numbers here on the right-hand side first. I'm going to say, just put marks here. Let's say we went by 10, so see if we can fit this all in. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. Perfect. They gave us the right number of boxes to be able to do this. So I'm going to take them all out and I'm just going to say, let's do this. Let's say we go up here to 50 and 100. And actually, whoops, that's funny. Sorry, I don't know what's doing there. Let's go by 20s just so you see it. Let's say that's 20. That's 40. Just a little bit closer together so we can more easily find our numbers that we're using. 80, 100, 120, 140. Now, I could make it nice and steep. I could say this is 1 hour, this is 2 hours, this is 3 hours. And we could graph it like that. And let's graph it like that. Why not? I'll show you it that way first, and then I'm going to spread it out a little bit. I'll redo it and spread it out so you can see what, if you kind of really took up the full graph, what it would look like. And it'll be really the same information graphed. Okay, so let's say at 0 hours, it's 30. So here she's charging 30 at 0. At 1, it's 65. It's right there. At 2, it's 100. Right there. And at 3, it's 135. Right there. Okay, so if I was to take a line and graph it, I could say starting there, running up to there, and beyond, because she could continue working past that if she needed to. That's what it would look like. And that's a perfectly acceptable graph, no problem at all. But I prefer to kind of give our graphs a little bit of breathing room. I just prefer to take up the space if we've got it. So I'm going to count the number of boxes here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to go every 4 boxes is going to be 1. So that's 1, that's 0, that's 1. By the way, that's 0 as well for the y-axis. Going another 4 boxes, that's 2. Another 4 boxes, that's 3. Why am I choosing to do this? Because now I'm just going to kind of stretch the graph out to fill in the full space, and it gives us a little bit more breathing room. So if we then graphed, we would say $30 when it's 0. After 1 hour, it's 65. It's right there. After 2 hours, it's 100, which is right there. And after 3 hours, it's 135, which is right there. And so and again, put an arrow to say there's no reason why we had to stop there. And that's a nice solid graph. Okay, we don't have every single line marked, and we took up the full amount. And by the way, I just want to point out what this graph could do. When you, not just my graph, but any graph, if you graph it correctly, you could say, okay, well then, what would be the cost of 2.5 hours? So I'm going to go here and I'm going to say, I'm going to check at 2.5. The input is 2.5, and then I'm going to follow it over and say, what would it be at 2.5? And we would see it says 120-ish. Might not be exactly perfect, but let's test it out. Let's take our equation and say C equals 35x plus 30 and plug in 35 times 2.5 to see how well our graph did at predicting what the cost would be for 2.5 hours. Okay, 35 times 2.5. I'm going to calculate that down here and then erase it. 35 times 2.5. 5, carry the 2, 15, 17, 0. 2 times 5 is 10, carry the 1. 2 times 3 is 6, plus 1 is 7. And 5, 7, 8. What am I doing wrong? Ah, let me try this again. Sorry, I realized what I did wrong there. Okay, I didn't do anything wrong. I was just thinking about it wrong. 35 times 2.5 is 25. Carry the 2. 3 times 5 is 15 is 17. 0. 2 times 5 is 10. Carry the 1. 2 times 3 is 6 plus 1 is 7. And we get 875. And there's one number behind the decimal here. So we put one number in our answer behind the decimal. And we get 87.5 or 8750. That seemed low to me, but then what I realized is, oh, right, of course, I have not added the extra $30 that she charges. So I got 8750, just clearing that out of the way. Sorry, I went a little overzealous there. I got 8750 there, plus 30, and 8750 plus 30, I'm just going to write this and then I'll erase it, would be 57, 117.50. 117.50. Cost would be 117.50. And how did we do predicting that? Well, it's pretty good. We actually predicted it around 120, and this is really pretty close to 120. So that's a really pretty reasonable estimation of what it would cost. So you can see that graphs can do that. They can estimate for you what other values would be that you didn't calculate.